Here we are with 1.E.1 homework. We are balancing equations for 3.60. The first one, N2O5 yields N2O4 plus O2. Both sides have 2 N's, but the right side has 6 O's, the left side only has 5. So we know we're going to need to double this at least to get more O's on the left. Of course, that doubles the N's, that's 4 N's. So we have to double here. 2 times 5 is 10, 2 times 4 is 8, plus 2 is 10. We now have it balanced. KNO3, once again, we have 1 K, 1 N on both sides, but 3 O's and 4 O's on the right means we're going to have to at least double that to get more O's on the left. 2 K's mean I need to double this, so 2 K's, 2 K's, 2 N's, 2 N's, 6 O's, 4 plus 2 is 6 O's. Letter D, NH4NO3 yields N2O plus water. I have 2 nitrogens, 4 hydrogens, so I need 2 waters, 3 oxygens, and 3 oxygens, so that works. NH4NO2 yields N2 plus water, 2 N's, 2 N's, 4 H's, 2 waters, 2 oxygens, and 2 oxygens in the nitrite ion. NaHCO3 has 1 sodium. This has 2, so I need to double this. That gives me 2 H's and 2 H's, 2 carbons, 1 plus 2, 2 carbons, 6 oxygens, 3, 4, 5, 6 oxygens. P4O10, 4 phosphoruses, so I need 4 in front of H3PO4. That's 12 H's, so I need 6 waters. If you take this 10 O's and that 6 O's, you get 4 times 4 is 16 oxygens. Moving on to HCl plus CaCO3. I only have 1 chlorine here, but I have 2 here, so I need to double this. That's 2 H's, 2 H's, 2 chlorines, 2 chlorines, 1 calcium, 1 calcium, 1 carbon, 1 carbon, 3 oxygens, 3 oxygens. 1 aluminum, 2 aluminums. I need to double that. 3 sulfates. I need to triple that. 2 Al, 2 Al. 6 H's. I need to triple that. 3 sulfurs, 12 oxygens, 12 oxygens. CO2 plus KOH, 2 K's. I need 2 K's here. And that does it. That takes care of it. CH4 plus O2 yields CO2 plus water, 4 H's, 2 waters. 2 plus 2 is 4 oxygens, so I need 2 O2's here. Be2C, that's 2 berylliums, so I'm going to need 2 in front of the beryllium hydroxide. That ends up giving me 4 oxygens, so I'm going to need 4 waters to give me 4 oxygens. That's 8 hydrogens. I have 4 plus 4 is 8 hydrogens. Copper, nitric acid, copper 2 nitrate, and nitrogen monoxide plus water. Starting out, I've got 1 copper, 1 hydrogen, 2 hydrogens here. That's 2 nitrogens, and 2 plus 1 is 3 nitrogens. So I'm going to at least need to double this. So I'll try 2 here, 4 here. That means 2 here. That means 2 here. 4 nitrogens. Up, I only have, I've got 2 times 2 is 4, plus 1 is 5 nitrogens, so that's not going to work. So let's try doubling everything again. At least double this. About 8 hydrogens. 4 waters. We could try 3 coppers, 2 NOs, 3 coppers, 8 hydrogens, 8 nitrogens, 6 plus 2 is 8 nitrogens, 24 oxygens, 3 times 2 is 6, times 3 is 18, plus 2 is 20, plus 4, 24 oxygens. Got it to work. Sulfur plus HNO3, H2SO4 plus NO2 plus water. I see I've got 2 H's, and 2 H's is 4 H's, so I need at least a 4 here. That 4 means I'm going to need a 4 here. So that gives me 12 O's, and 8 plus 4 is 12, plus 1 is 13 O's. So I'm going to have to increase my hydrogens. Let's go up to 6. That would give me 6 NO2s. Now we've got 1S, 1S, 6 H's, 2 plus 4 would be 6 H's. 6 nitrogens, 18 oxygens, 4 plus 12 plus 2, 4 plus 12 plus 2 is 18 oxygens. So I took care of that. NH3, water. I'm going to need to triple the water and double this to get an equal number of hydrogens. Least common multiple of 3 and 2 is 6. 2 nitrogens, 2 nitrogens. 3 oxygens, so I'm going to need 3 here and 3 here. 3.64, I've copied to the best of my ability the picture that's in the book and trying to figure out which of the following equations best represents the reaction shown in the diagram. So based on this reaction, we appear to have 1, 2, 3, 4, 5, 6 A's plus 1, 2, 3, 4, 5, 6 A's, 1, 2, 3, 4 B's, right? And then yields 4 C's and 2 D's. All this is divisible by 2, so it would be 3A plus 2B yields 2C plus D, which is letter D. 3.70 says when baking soda, sodium bicarbonate, or sodium hydrogen carbonate, NaHCO3, is heated, it releases carbon dioxide gas, which is responsible for the rising of cookies, donuts, and bread. Letter A says write a balanced equation for the decomposition of the compound. One of the products is Na2CO3. So NaHCO3 decomposing to make Na2CO3. The other products would be water and carbon dioxide, which helps rise the cookies, donuts, and bread. And then it says letter B, calculate the mass of NaHCO3 required to produce 20.5 grams of carbon dioxide. So starting with the 20.5 grams of carbon dioxide, I changed it to moles, got 0.466. I took the moles of carbon dioxide times the 2-to-1 ratio for sodium hydrogen carbonate to carbon dioxide, got 0.932 moles of sodium hydrogen carbonate. And then in the last step, I changed moles to grams by multiplying by the molar mass of NaHCO3, which is 84.01 grams. And I got 78.3 grams NaHCO3. 3.76 says nitrous oxide, N2O, is also called laughing gas. It can be prepared by the thermal decomposition of ammonium nitrate. The other product is water. A, write a balanced equation for this reaction. So NH4NO3 decomposes when heated to make N2O plus 2 waters. Letter B, how many grams of N2O are formed if 0.46 moles of NH4NO3 is used in the reaction? 0.46 moles NH4NO3 times 1-to-1 ratio of N2O to NH4NO3 means 0.46 moles of N2O are formed. 0.46 moles N2O times 44.02 molar mass of N2O per mole equals 20. 20 grams N2O, and that's with 2 sig figs. 3.82 says, consider the reaction N2 plus 3H2 yields 2NH3. Assuming each model represents 1 mole of the substance, show the number of moles of the product and excess reactant left after the complete reaction. So looking at the picture has 3 pictures of N2, so that's 3 moles of N2. It has 10 pictures of H2, so that's 10 moles of H2. So looking at that, it's supposed to react in a 1:3 ratio, so 3 moles of N2 is going to need 9 of the 10 moles of hydrogen, and we'll end up with a 1:3:2 or 3:9:6 mole ratio of N2, H2, and NH3. So I need to draw a picture with 6 moles of NH3 in it. So here's my picture with 6 moles of NH3, but I started with 10 moles of hydrogen. I only used 9, so 10 minus 9 means I also have 1 mole of hydrogen left over right here. That's how I would draw the particulate diagram. 3.84. The depletion of ozone in the stratosphere has been a matter of great concern among scientists in recent years. It is believed that ozone can react with nitric oxide that is discharged from high-altitude jet planes, such as the SST. The reaction is O3 plus NO yields O2 plus NO2. That's a balanced equation, 1 to 1 to 1 to 1. If 0.740 grams of O3 and 0.670 grams of NO react, how many grams of NO2 will be produced, and which compound is the limiting reagent? So what we need to do here is change grams of O3 to moles, change moles of O3 to moles of NO2, then take the grams of NO, change that to moles, and then change moles of NO to moles of NO2, and notice that the O3 makes fewer moles of NO2, so O3 is limiting. I'm also supposed to change moles of NO2 to grams. So I'm going to take 46.01 grams over 1 mole and find that my 0.0154 times 46.01 is 0.709 grams NO2 are formed. O3 is limiting. Now finally, the third part of the question, calculate the number of moles of excess reactant left over. The excess reactant is the NO, the nitrogen monoxide. I know I'm going to use up all my O3, so 0.0154 moles of O3 times 1 over 1 is 0.0154 moles of NO used up. I started with 0.0223 moles of NO, so 0.0223 minus 0.0154 is 0.0069 moles of NO left over. So that's all 3 parts of 3.84. And the last question, 3.90. Nitroglycerin, C3H5N3O9, is a powerful explosive. Its decomposition may be represented by 4 C3H5N3O9 yields 6 N2 plus 12 CO2 plus 10 waters plus 1 oxygen. This reaction generates a large amount of heat and many gaseous products. It is the sudden formation of these gases together with their rapid expansion that produces the explosion. A. What is the maximum amount of O2 in grams that can be obtained from 2.00 times 10 to the second, or 200 grams of nitroglycerin? First, change 200 grams to moles. C3H5N3O9 adds up to 227.11 grams. That gives me 0.811 moles of C3H5N3O9. Then change moles of nitroglycerin to moles of oxygen. That's a 1 to 4 ratio. So I get 0.22 moles of oxygen formed. 0.22 moles of oxygen, since O2 weighs 32.00 grams per mole, is 7.04 grams of oxygen is the theoretical amount that should be formed. Letter B, calculate the percent yield if the amount of oxygen generated is found to be 6.55 grams. 6.55 over 7.04 times 100 is a 93% yield.